From the celestial waltz of planets to throwing a ball, physics governs our universe. Sir Isaac Newton gifted us with 3 fundamental laws of motion. These laws are the bedrock of classical mechanics, explaining how objects move and interact. Newton's laws are the musical notes and the objects within it, the instruments. Understanding these laws allows us to predict the trajectory of a baseball or launch a rocket into space. Let's embark on a journey into the fascinating realm of Newtonian mechanics. Picture a lazy Sunday afternoon. The sun is shining through the windows, casting a warm glow across the room. You're relaxing on the couch, deeply engrossed in a book, feeling completely at ease. The world outside seems to fade away. Suddenly the doorbell rings, jolting you from your peaceful state. Your heart skips a beat as you snap back to reality. Newton's first law of motion, also known as the law of inertia, states that an object at rest will stay at rest unless acted upon by an external force. This fundamental principle of physics explains so much about our everyday experiences. For instance, a parked car won't suddenly drive down the street. It needs a push or some other force to set it in motion. Similarly, you remained on the couch because no force was strong enough to overcome your inertia of rest. Your body was perfectly content to stay put. This concept of inertia also explains why we wear seatbelts in cars. When a car suddenly stops, your body wants to keep moving forward. The seatbelt provides the external force to restrain us, preventing injury by holding us in place. It's a simple yet crucial application of Newton's first law. Let's talk about shopping carts. They might seem simple, but they can teach us a lot about physics. Imagine pushing an empty cart through the grocery store. Easy, right? It glides smoothly with little effort. Now picture it filled with groceries. Suddenly, it's much harder to push. Newton's second law of motion states that acceleration is directly proportional to the force applied and inversely proportional to its mass. This means the more mass an object has, the more force you need to move it. Force is a push or pull, something we apply to move objects. Mass is the amount of matter in an object which determines how heavy it is. And acceleration is the change in velocity, or how quickly something speeds up or slows down. The more force you apply, the faster it accelerates. This is why pushing a car requires a lot of effort. A gentle tap sends a tennis ball rolling slowly. It barely moves. But a powerful serve sends it whizzing across the court at high speed. Pushing a loaded cart requires more muscle than an empty one. You can feel the difference in effort. This law helps us understand why a small car accelerates faster than a larger truck with the same engine power. The truck's greater mass requires more force to achieve the same acceleration. It also explains why a feather falls slower than a bowling ball. Though air resistance plays a role too, the mass difference is key. Have you ever jumped off a small boat onto a dock? It's a simple action, but it reveals a profound principle of physics. You push off the boat to propel yourself forward, but the boat moves backward. This is a perfect example of how forces work in pairs. This illustrates Newton's third law of motion, a fundamental concept in physics. It states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. When you push against the boat, action force. The boat pushes back on you with an equal force, but in the opposite direction, reaction force. This interaction is what allows you to move. Think about a rocket launch. It's a dramatic demonstration of Newton's third law. The rocket expels hot gas out of its engines, action, and the gas exerts an equal and opposite force on the rocket, propelling it upward, reaction. This is how rockets are able to lift off and travel into space. This principle is fundamental to our understanding of how objects interact. It applies to everything from the smallest particles to the largest celestial bodies. When you walk, you push against the ground, action, and the ground pushes back on your feet, reaction, propelling you forward. This is why you can move. Even typing on a keyboard involves this law. Each key press is an action, and the resistance you feel is the reaction. Newton's laws provide a framework for comprehending the universe's elegant dance of motion and forces. They help us understand the intricate ballet of celestial bodies and the forces that govern their movements.